In this section, we will look at how to solve linear equations, and we'll also get to absolute value equations. At this point, I expect you to be able to solve linear equations, and so we're going to do a quick review of some techniques that we can use to help us solve these things. I have some steps up here. The first step we like to take when we're solving linear equations is to distribute on both sides if we see a distributive property. All right. We can combine like terms on either individual side if we see any like terms. And last but not least, we can clear fractions if we see any of those. All right. And so this is working on any individual side except for the clear factoring. I'm calling this simplifying. That's the first thing I'm going to do. Second thing I'm going to do is I'm going to get my variable terms on one side of the equation and my constant terms on the other side of the equation using addition or subtraction. Then I'm going to isolate the variable using multiplication or division. And now, after I do that, I'll have my equation completely solved. X is by itself, or whatever variable we have is by itself, and then we know that we're done. I can always check my solution by substituting it into the equation, in the original equation that I'm given, to ensure that both sides still are satisfied when I substitute that solution in. And so I'm going to look at this example first, and then we're going to look at this second example with those fractions there. To look at this first example, if you notice, we have a distributive property here. And so that's the first thing we're going to want to do on both sides of the equation. Distribute this negative 2 to that 4x minus 5. And if I do that, I'll get 3x minus 8x plus 10 equals 2x minus 11. With that distributive property, I'm opening up to combining like terms. I get negative 5x plus 10 equals a 2x minus 11. All right, now I'm at the point where I've simplified both sides. My right-hand side didn't actually need to be simplified. And now I'm ready to go to step 2, which is to get my variable terms on one side and my constant terms on the other. I'm going to choose my left-hand side for my variables to stay, so I need to get rid of this 2x by subtracting 2x from both sides. With that subtraction, I get a negative 7x plus 10 equals a negative 11. I can subtract 10 from both sides so that my variable term can only be on that side, and I have my constant or my numerical terms on the right-hand side. And last but not least, I can divide both sides by a negative 7, which is being multiplied by that x. And I'll get that x equals 3. And therefore, my solution is x equals 3. And so if I substitute 3 back into this original equation here, I should get that both sides do remain equal. One way that you can write your answer is as a solution set. And when we write solution sets, we usually use our squiggly brackets, put our solution in there, and then close our squiggly brackets. All right, that's one way to write our answer. Another way is to write it just as we see it here, x equals 3. Okay. Our next example, as you can see, involves some fractions. And one way to solve this problem with these fractions here, 4/3 x minus 3/2 equals 11/6x plus 5, is to multiply both sides by the lowest common denominator of these fractions, which is 6. So I'm going to come over here and I'm going to multiply this left-hand side by 6. Then I'm going to multiply this right-hand side by 6. With that, I'm going to have to distribute the 6 to basically everything in this equation here. And when I distribute, things are going to cancel. That's why I chose the lowest common denominator. I'm going to have 3 goes into 6 2 times, so I get 8x. 2 goes into 6 3 times, so I get minus 9. 6 goes into itself 1 time, so I get an 11x. And 6 times 5 is 30. Now I have an equation without any fractions, and I've basically simplified both sides, right? Now, Clearing fractions involves, unlike distributive property and unlike the combining like terms, it actually requires you to work on both sides. Whereas distributing or combining like terms, you're only working on one side. But now that I have that, I'm going to get my variable terms on one side. Unlike the last time, I'm going to pick my right-hand side to put my variables, right? And so since this 8x is on the left-hand side, I'm going to subtract 8x from both sides. I'm going to get a negative 9 equals 3x plus 30. My variable term is on this side, not on the other side, but I still have this constant term lingering out here. So I'm going to get rid of that by subtracting the 30 from both sides. And I'll get negative 39 equals 3x. Excuse me there. And I'm almost completely isolated, have my variable almost completely isolated. All I need to do is divide both sides by 3. And I'll get that x equals negative 13. All right. And so I see my solution here. And if you wanted to write it as a solution set, which you might see in your textbook, you'll have your answer given in that manner. Okay, so those are two good examples to review how we solve linear equations. I want to get to two other examples where some interesting things sort of happen. And in this example, while we get started, we have a distributive property here. On the left-hand side and on the right-hand side, we can combine those two like terms and these two like terms. So we got a lot of work to do before we get into the nitty-gritty of getting variables on one side and constants on the other side. Okay, simplify this, I get 6x minus 21 plus 5 equals, well, combine these two like terms, I get 6x. Combine these two like terms, I get minus 16. Notice on that left-hand side, I've opened myself up to having like terms. Negative 21 plus 5 is negative 16. So if I look here, I have an equation with identical sides, right? Identical expressions on each side of that equation. Let's see what happens when I have identical expressions on each side. I'm going to continue to carry on like I would normally would, right? I'm going to get my variables on the left-hand side. That means I need to get rid of this 6x here. Well, my variables cancel and I get negative 16 here. I get negative 16 on my right-hand side. Well, negative 16 does equal negative 16, so what has happened was my variables canceled, and I ended up with a true statement. This type of an equation, any kind of equation where this happens, is called an identity equation. That means no matter what variable I have, since I have the same thing on both sides of my equation, my variables can be any real number. Right? So if I want to know the solution to this thing, it's going to be all real numbers. All right? And it's given by that symbol there, which is a double barred R. Let's look at one more example that's interesting as well. If I look at this example, I set myself up for a distributive property here. This 3 can be distributed to that x plus 3. And if I do that, I get 3x minus 8 equals 3x plus 9 minus 1. Still can combine like terms with those two terms over there. So my left-hand side stays the same. I get a 3x plus 8. Now it looks almost identical, but I have a subtraction and an addition sign, so it's not identical. So I'm going to get my variable terms on this left-hand side over here, so I'll subtract 3x from both sides. And I'll get negative 8 equals positive 8, which is definitely not true. That's false. Okay, so my variables canceled, and I got a false statement. When that happens, we call this a contradiction. Okay, so we thought it was an equality, but after we simplified, we realized that there's no way that these things are going to be equal. Our variables cancel, and we got something that's totally different. So we call that a contradiction. And that means no matter what we plug in for x, they're going to cancel anyway on both sides. So I'm not going to have any kind of solution whatsoever. So this equation has no solution. When that happens, we use this symbol here, circle, with a slash through it. That stands for the empty set. Okay, so you can either write the word no solution, or you can use this symbol here when you have a contradiction equation. And that's all for linear equations.